Okay, so the next question we have is the treatment of alkyl chloride with aqueous KOH lead to the formation of alcohol, but in the presence of alcoholic KOH, alkenes are major product. This concept we have used multiple time in the previous questions what we did, but now they are asking the reason why. In presence of aqueous KOH, why we get alcohol, and in presence of alcoholic KOH, why do we get alkene? Why does elimination takes place in alcoholic KOH and substitution take place in aqueous KOH? So basically the question they're asking, for example, let me take CS3CH2Cl. This is alkyl chloride. When you react this with aqueous KOH, why do you get CS3CH2OH, which is a substitution reaction, nucleophilic, but the same thing CS3CH2Cl, when you treat with alcoholic KOH, we don't get CH3CH2OH, we get here CH2 double bond CH2. A beta elimination reaction takes place. This we have used this concept many times previously, right? So they're asking why, what is the reason for it? So it's a very good question. So let us try to understand it. Now, see, let me just first give you the whole concept, then I'll give you ideal answer also. When aqueous KOH is there, okay, and you add aqueous means water is also present. So what happens? It breaks in this form K plus and OH minus. Now if you see here, because of this water presence, this OH minus quantity has increased too much into the solution. Because of this, what will happen? This CS3CH2Cl and this OH minus, this Cl, if you see, it is already polar, it is negative, and this carbon get positive, and there are so many OH minus over here. They force this Cl to give this CH2 to them, and they attack this, and the Cl minus leave this, and that's why you get a alcohol formation. Because of this OH minus, they start surrounding it, just like a war. This country has been completely surrounded by this OH minus, and now it is forced to eliminate from here, and the substitution of OH minus will take place. So I hope the first reason is clear why aqueous KOH give a substitution. Now coming back to our alcoholic KOH. In case of alcoholic KOH, what happens? This alcoholic KOH act as a base. Okay. Now it does not break completely. Like we can say here it was getting completely, which for 100 KOH, 100 will break. But here this 100 K plus and 100 OH minus we are not getting. This quantity of this OH minus is very less. Apart from this, alcoholic KOH, it also breaks C2H5O minus form and H plus form. It also breaks sometimes in the alcoholic KOH form in C2H5O minus and H plus form, and this becomes ethoxide ion. This is known as ethoxide ion, and it is very good negative charge. So what will happen to our ethyl chloride? This ethoxide ion, apart from OH minus coming and telling what has happened here, that to give me this nice and go away from here, ethoxide ion, what it will do, the hydrogen present here, so there are two hydrogen, right? So I will just write one hydrogen here. This ethoxide ion will ask this hydrogen, you come up with me, and it will convince this hydrogen, you come up with me. So that what will happen, because of this, hydrogen will leave its electron and go with O minus, and what will happen later on, this two electron which is left behind here will come here and make a double bond, and because of which a alkene formation will take place. Cl will also leave from here, and one electron from here will join this one electron from here, and it will form a alkene. So this was the only reason why we get alcoholic KOH as a elimination reaction, because it is happening at beta carbon. You can see this is beta. So this not this hydrogen, this hydrogen actually. So you have to remember that beta hydrogen will get substitute eliminated from here. Okay. So let me tell you the ideal answer for it. In aqueous medium, the water KOH will completely dissociate. Just now I told you, and to give OH minus ion. This being a strong nucleophile will bring about the substitution of alkyl halide to form alcohol. Already told you about this. At the same time, the OH minus ions will be highly hydrated also. They will not be able to abstract proton from the beta carbon. Okay, this is beta carbon. So OH minus ion does not have ability here to extract the hydrogen from here. Okay, this hydrogen I am talking about. In other words, aqueous medium OH minus will behave as a weak base, okay, and elimination leading to alkenes will not be visible. So weak base cannot remove the hydrogen from it. But in case of alcoholic AOH, the solution also contain ethoxide ion, just now which I told you, in addition to OH minus ion. They being a stronger base. So who is more stronger, OH minus or ethoxide? Ethoxide is more stronger. Will abstract the hydrogen ion from the beta carbon. Just now I told you, from here a beta carbon, this one, this hydrogen will be extracted from this ethoxide. Okay, because of this, what will happen? Giving alkene as the product as a result of dehydrohalogenation. So halogen will also go and hydrogen will also go. So this is your ideal answer. I hope you have understood. Thank you.